Good morning, students. Today we continue our lecture on study of compounds ammonia. This lecture is presented by me, Pranit Ghatak, your chemistry teacher. So let's begin. Today's topic is catalytic oxidation of NH3. Today we're gonna do two topics. Mainly, number one, catalytic oxidation of NH3, as well as the reaction of NH3 in presence of oxygen. Okay, so let's begin. NH3 or ammonia does not burn in air or support combustion. Okay, NH3 doesn't burn in air or it doesn't support the combustion either. Okay, but it burns in O2, that means it burns in oxygen with a yellow flame, forming N2 nitrogen and water vapor. Okay, NH3 doesn't burn in air or support combustion, but in presence of O2, it gonna burn with a yellow flame, forming nitrogen and water vapor. Okay, so let's see the reaction here. 4NH3 plus 3O2, that in presence of oxygen, that is 3O2. 4NH3 when burn in presence of oxygen, it gives N2 and H2, that is 2N2 plus 6H2, that means nitrogen and water vapor. Okay, in this reaction you can easily see that all the reactants, that is NH3 and oxygen, are gaseous, as well as the products, that is the N2 and water, that is water vapor, both are in the gaseous in state. So this is the reaction where all the chemicals needed, that is reactants and products, all are gaseous in nature. Okay, so if anyone asks to give you an example of a reaction where all the reactants and products are gaseous, you can surely give this reaction as an example. Okay, so remember, NH3 doesn't react with air, but in presence of oxygen it burns with air and react with oxygen and give nitrogen and water vapor, nitrogen as a gas and water vapor. Okay, and the flame of the reaction will be yellow flame. Okay, so let's move to the next topic, that is catalytic conversion of ammonia. Okay, so before that we would have to see this picture, that is ammonia is used to manufacture the nitric acid, that is HNO3. Okay, so ammonia is used to manufacture nitric acid, and this process involves the catalytic oxidation of ammonia and occurs in 3 stages. Okay, to produce the nitric acid from ammonia, this process is going to convey through 3 stages. Okay, and this process is being named as catalytic oxidation of ammonia. Okay, so these 3 stages are: number 1, where NH3 gets oxidized by the help of oxygen, that is 4NH3 plus 5O2, that gives NO, nitric oxide, plus H2O. This nitric oxide gonna oxidize itself further by reacting with oxygen, and it will give nitrogen dioxide, that is NO2, nitrogen dioxide. Okay, and this nitrogen dioxide in stage 3, and this nitrogen dioxide further will be oxidized by oxygen, and it will be reacting with water as well. So first two step, that is stage 1 and stage 2, when ammonia is being reacting with oxygen producing nitric oxide, and this nitric oxide further being oxidized with oxygen and producing nitrogen dioxide. But in the third stage, this nitrogen dioxide is not being only reacting with oxygen, it is also reacting with water. So in the first 2 steps, ammonia and nitric oxide both only reacted with oxygen. Okay, only reacted with oxygen and giving their products. But in case of third stage, the nitrogen dioxide is being reacting with oxygen as well as the water and giving nitric oxide, HNO3, that is 4HNO3, this is 4NO2 plus O2 plus 2H2O, that gives 4HNO3. So this is the reaction. This is the catalytic oxidation of ammonia. By this catalytic oxidation of ammonia, we can easily form nitric acid. Okay, and this nitric acid can be used in the commercial purpose as well. Okay, so this catalytic conversion or catalytic oxidation of ammonia goes through three stages. Okay, stage 1, stage 2, and stage 3. Okay, so let's explain this process, this catalytic oxidation, by this simple diagram. Okay, so by here, this is the initiation path. Here we, the NH3 and oxygen both enters through this point. Okay, this initiation point, and here is a platinum tube is being used. In this tube platinum is being used. Okay, and this platinum, why is platinum is being used? Because platinum is being acting as a catalyst. Because platinum is being used as a catalyst. Okay, acting as a catalyst. Okay, in this tube, when NH3, the ammonia and oxygen is passed through the platinum catalyst, we have to heat up this tube. Okay, so we have to use some Bunsen burner in this place. What happened here? The oxygen is being get energetic. Okay, and it will be reacting with the ammonia in the presence of platinum catalyst. It will form NH3 here, and by this tube it will pour into this container as well. Okay, so this is the actual pathway by which we can do the catalytic oxidation of ammonia. So we have to initiate the ammonia and oxygen by this path, where the tube is contained of platinum. This platinum is being using as acting as a catalyst. So when ammonia and oxygen is being passing through a platinum tube, we have to heat up by using Bunsen burner. Then in the activated medium of this heating medium, what we can say, the oxygen and NH3 gonna react to each other and give a product of HNO3, and this HNO3 will be poured into this container as well. Okay, so in this topic, in this today's lesson, we have discussed two things, that is catalytic oxidation of NH3 as well as the reaction with oxygen of ammonia. Okay, so I hope you have understood this part very well. If you have any kind of doubt, you can always ask me in the comment section below. Okay, so that's it for now. Thank you.